Phoenix Field Notes, kicking off ElixirConf 2023. So I was here in Orlando 7 years ago, I think, for another conference. So it's been 7 years since then, which is pretty wild. But today, this talk is more of kind of some lessons learned using Phoenix and LiveView in Anger, especially at a company with developers that aren't necessarily versed in Elixir, coming over from other ecosystems. So that company, you've probably heard of them, is Fly.io. They're the reason I'm able to work on Phoenix and not burn out. So definitely check them out. We deploy your Elixir, or basically anything that runs in Docker can run all over the world. So we'll see a little bit how that works later. But definitely check us out. It's the best place to run your Elixir apps. And one of the most exciting things, took us 10 years, is Longpole fallback. So I said I'd never do this. But one of the lessons I've learned of using LiveView and Phoenix in Anger at a product company is I actually have metrics on WebSocket requests that fail. So one of the issues that we were seeing at Fly is 2% of our users would just fail WebSocket connections for reasons that weren't our fault. And historically, if you find IRC, Slack, Elixir forum posts, I said that to be clear, we have Longpole support. So Phoenix channels was the first feature of the framework. It shipped with WebSockets and Longpole support, but you had to write the logic to fall back on your own. So it wasn't automatic. And the reason it wasn't automatic is because it's a huge pain in the butt to actually do this properly. And it's something that I didn't think we needed to do. But working at a product company, it's we actually had metrics on users unable to connect over WebSockets, and it was 2% of our traffic, which is non-zero, right? And trying to find out why that failed is also, it's kind of ridiculous. Basically, it's the reason why I didn't want to solve this 10 years ago, is what we were seeing is WebSocket requests for some clients due to unknown reasons, maybe some proxy in between, would allow the WebSocket upgrade to complete. So the client with WebSocket sends a HTTP 101 switching protocols request, and the server says, yes, you can upgrade this to a WebSocket. And the proxy, or some piece of networking gear in between the server and the user, would allow the WebSocket to upgrade. What the JavaScript client would trigger WebSocket on open, everything is good, and then the proxy would just drop all traffic on the floor. So it made Longpole fallback, even on your own, impossible with the features of the framework, because the WebSocket client on the JavaScript side sees that it has a good WebSocket connection, and it doesn't find out that it's bad until 30 seconds later when the heartbeat fails. And there's no way that we can get in the mix in whatever networking configuration is dropping this traffic on the floor. So to make a long story short, in the next release of Phoenix, you'll be able to say, fall back to Longpole, and you'll give it a timeout. And we're going to do some things for you to make this work. But we basically shipped a feature in Phoenix, this is several months ago, to enable Longpole fallback on Fly. And then I extracted the logic out of Fly, and we're putting it into Phoenix. And it's essentially, we added this ping feature to Phoenix channels, which allows the client to, when the WebSocket upgrade happens, we immediately ping the server. And when we get the acknowledgement back, we know that we actually can send WebSocket frames over that connection. So this 3 seconds here is going to say, as soon as the document is ready, try to establish a WebSocket connection. If you get one, ping the server with a packet and come back, and then we're good. If any of that fails within your timeout, it's just going to force Longpole fallback. So the only failure mode here is if the client is so slow, their latency is over 3 seconds, and they could have had a good WebSocket, then they'll be forced to LongPulling. But you could probably argue that 3-second latency probably would be better served over a Longpole anyway. So we're going to ship this. It's going to be a single line in your configuration file. Your endpoint, by default, has Longpole commented out, so that will be commented in. So it will just work. And part of working with Fly is I also added binary support to channels over LongPulling. So now the Longpole, whether you're using channels or LiveView, is full feature parity across the transports. So there's no it's no longer a second-class citizen. Every feature is just going to work. Uploads over LiveView is just going to work. So Longpole will be first class, even though it took us 10 years, and I wish that we didn't have to do this. It's definitely going to help people out across the world. And the other thing is we also will memoize the fallback. So let's say a user has this weird network configuration. It takes multiple seconds to fall back to LongPulling. We will memoize that for that session of the browser, and the next full page refresh will just immediately use LongPulling. And another one of these like lessons learned that's not super exciting, but I think is going to lead to a quality of life improvement is this idea of like this well-formed data structure in your app. And if you've looked at the ToDo Track application that I open source, I kind of played around with this idea, but I'm not going to call this a pattern because it's not a pattern. But time and time again, working on production apps, especially seeing what we've done at Fly, is we end up having the need for this like rich data structure down like multiple levels in our code base, but we don't have it. So like at Fly, we do a bunch of communication with external services. So the LiveView app is like the Fly dashboard is a LiveView app, but it's talking to like a GraphQL API, it's talking to a Rust API, it's talking to a Go API. And we have all this configuration about how to talk to the API on behalf of a user. So we're passing down like just arbitrary GraphQL configuration down multiple levels. And you don't know that you need this information until like late in the feature development, or the moment you need to talk to another service, you now have to like start up in the plug pipeline, get the information in the request, and pass it down a bunch of levels. So any kind of production app often needs kind of a lot more rich information about what the current user or what the client has, what we need to know about them. So we're going to generate a data structure in your app. It's not a library. It's not anything. It's just going to be out of the box, this little data structure, app defined, and it's going to have information about what this user is. And this could be a plug request. This could be a Phoenix LiveView. This could be an open job, right? You always have some kind of information about how you're scoping this operation that's happening in the system. And most production apps ultimately need to have some kind of audit log. So you usually need like a client IP and a user agent. And this kind of information is when just passing like a current user to a function to operate, let's say to create a post, to do anything, even anything basic, you ultimately end up needing to pass this information on the side along, and it becomes a huge pain the more and more requirements you get in your system. So now you'll have a well-formed data structure with a Phoenix new app that will be used with your like Phoenix Gen Live and your context generators that ultimately will just get passed down, and you can operate on that. And it can do a lot of nice things that otherwise would require a bunch of refactoring. And one of the things we want to do out of the box for your like CRUD LiveView generators is just make the app real time across browser tabs. And the reason we haven't done that yet is because there's no way to easily scope like what a user is looking at, right? Because if out of the box you run like Mix Phoenix Gen Live, and you can say, oh, we can scope this to the current user, and we can make it all work, and we can make it pretty. It would demo really well. The browsers would just update. I could show it off here. But the moment the user wants to build anything real, they were having a topic for that page just to the current user. So they would have to go say like, well, I have actually like an organization in my app, or a team should actually see updates broadcast back and forth. And they'd have to go find all their pub sub code and scope that properly. So there needs to be, even from like the most basic CRUD example, kind of this idea of like the scope. So one example would be if you did like Mix Phoenix Gen timeline context, it out of the box could have a pub sub subscription, and you could pass the scope instead of like the current user. And by default, we're just going to scope this topic to the current user ID or the request ID. It could be an anonymous user, and the plug request ID could be in the scope, and you could just say, well, this is just going to be for the actual request, or it could be the current user ID. Or you change one line of code that generates the topic to use the organization ID. So it's like out of the box, even outside of like audit logging and client IPs, you need this like rich information, this rich data structure to pass down, because if we had passed the current user around, it immediately falls down the moment you want to grow your application. So small feature here. I think it's going to be quality of life improvement. I know just with what I've seen at Fly, we needed something like this, and I'd love to refactor to something like this. But I think in general, folks end up with something similar to this, so I think it would give people really a better starting point to grow their application, especially with our code generators. And one of the lessons at Fly as well, and really in the community, is that people are using distributed Erlang and distributed Elixir a lot less than I thought, at least anecdotally. So the Phoenix team shipped this tiny library called DNS cluster, and it ultimately allows you to have like a single line configuration to get your Elixir app cluster together. And we have great options in the community to do this. libcluster is one of them. So libcluster is by Paul, Bitwalker Paul, if you're familiar, and it has a bunch of different strategies for connecting nodes. It can do DNS, it can do a bunch of Kubernetes stuff. But to ship this out of the box with all Phoenix new applications, we wanted like the smallest possible dependency that had no other dependencies. So DNS cluster, it's like 100 lines of code with documentation, and it allows like a single line configuration for like the most basic clustering. So this is like using all Erlang standard library features. There's no external dependency that it needs, and you can just have it work with one line of configuration. And the reason that I ship this, outside of just wanting apps to work distributed by default, is like people were kind of triggering me by mentioning that they were using the Redis PubSub adapter. So show of hands here, who is using the Redis PubSub adapter that's not on Heroku? Anybody? Okay, we have a few. Okay, this is actually really encouraging. So I was seeing a lot of anecdotes. So if you're not familiar with Phoenix PubSub, by default it uses distributed Elixir. I added the Redis PubSub adapter because Heroku dynos don't network together. For some reason, they never figured that out, so I wanted PubSub to work on Heroku. So we added, okay, how do we do that? Well, you need some central data store. Redis is decent. We'll use that. So it was added as a crutch, and it should like never be used unless you absolutely have to. And basically, if you're using Heroku, that's your only option. But we were seeing anecdotes on this discussion on the forum about distributed Elixir not providing enough out of the box for people in the community. And several anecdotes came up about people saying that like they've been working for years in Elixir across projects, and they're seeing people just like as default bring Redis in just because like that's what they're familiar with is from like using Go. So this triggered me to say like, no, like this should just not be part of the equation. You shouldn't even have to think about it. And like even since we've shipped it, we've seen like more anecdotes, right? So it's like more people are using Redis than I thought, and greenfielding projects just with it as a matter of course. And it's like one of the great things about Elixir is like we don't need this infrastructure. So now it will just be a Phoenix new application. Will include DNS cluster, which like I said is like if you took the docs out and like the nice warnings, it's like 50 lines of code. And I think it's actually a good example to show that like Erlang distribution isn't actually this like mysterious process. Like if you have a TCP connection and a host name that you can get from somewhere, you can just call node connect on that and cluster your application. So I think if DNS discovery isn't right for your deployment, you can look at this code and say like, oh, I could roll my own clustering in like 50 lines of code. So I think it will also help like demystify this. But for the most part, whether you're using Fly, I think render.io as well, or sorry, render.com, DNS discovery should be like the simplest approach. It's going to be one line in your app. If you don't have it configured, you can pass ignore, and then it just does nothing. But otherwise, it's just going to start up one configuration, and your app's clustered together. And part of clustering, and part of this discussion on the Elixir forum is like people were like, well, the community is not providing enough primitives to really take advantage of Erlang distribution. And it kind of led me to reflect on like how we discuss distribution. Because I think we often focus on distribution being this like distributed systems, graph consensus, global coordination, CRDTs, and like to be clear, like Elixir is fantastic at tackling those. Like Phoenix Presence uses a CRDT. It's an amazing choice for these hard distributed system problems, but I think that we get lost in the discussion in the community about saying out of the box we don't have like a go-to RAF library, even though there is an Erlang one, but we focus too much on distribution meaning advanced distributed systems and less on like boring distribution and what like the boring distribution enables. So I'm saying things like RPC or just like basic PubSub. And like this can get you very far and just like removes layers of architecture and complexity. And I think we don't appreciate that enough or talk about that enough. So like I want people to think less about advanced distributed systems, even though it's fantastic. You want to build that in Elixir, do it. But I want people to think more about like boring distribution, saying like, okay, out of the box, my Phoenix app is distributed with DNS cluster. Like what does that gain me, right? Because most people think like, oh, this is just relegated to the territory of libraries. But it really just like removes a bunch of layers for you where you don't even have to think about a certain class of problems. And I think like going back to like the basics helps here, at least with my intuition, thinking about like what does distributed Elixir mean? Like what does that actually gain me? So if you think about like what message passing means, like if you're familiar with OO, a lot of people will say object orientation. I think if you go back to like Alan Kay, will be like, oh, you don't actually call a method, you send an object a message and it gives you an answer, right? So some OO lang like Ruby or JavaScript, I can just instantiate an object, right? And then I can send it the message increment, right? And then Elixir, we do something very similar where we like can start a process and then we literally send a message. Like a gen server call is just a message send with a reference, and then you get sent back a message for the response. But the thing that I think people miss, or the intuition, is like when you hear about this idea of like, oh, processes are location transparent, like this fancy word, like it means that like coming from OO, imagine any instantiation of an object made that object globally addressable in your cluster, just like as a feature of the platform. So I think if you are lacking an intuition of what this enables, just like imagine if you could instantiate an object in OO, in Java, or any other language, and like that thing had a global address that you can call methods on. Like that's what Elixir gives us, and this is what really unlocks like a layer of potential that people aren't thinking about, where it's like whatever library you're using, whatever abstraction you come up with, it can be messaged anywhere on the cluster just like by default. So like if someone released a library and they weren't even thinking about Erlang distribution, the fact that you can just call a process from anywhere means that you can now make that app distributed on your own just by sending a message to a process. So I think you should really think about like less about Raft consensus and more about just like what does having the ability of this like globally addressable thing in your app do for you. And one of like a boring example would be like how LongPulling works in Phoenix. So LongPulling, which is a hot topic today, makes use of Erlang distribution in like a simple but like really effective way. So the way LongPulling works is like we don't have a stateful connection, right? We're simulating the stateful connection over stateless HTTP. So how do we hold the state? Well, it's like the first time you send a message to the server saying, hey, I'm a Longpole client. We're going to start a process for you. You happen to load balance to node 1, and now that's holding the state of your Phoenix channel or your Phoenix live view. And we send you a result back saying like, here's the diff, or here's your channel message. And then you come back up to Longpole again, and oh, the load balancer sent you to node 2. Like, oh no, what do we do here? Like, oh, well, we better bring Redis in, we better bring some other central data store. It's like, no, we have a PID, it's globally addressable in the system by default, and we just send the PID to the client when they Longpole, and then when you Longpole back, we decode the PID, and we just call send on it, right? And like the Erlang distribution just knows how to message that thing. We didn't have to set up a separate connection, we didn't have to set up a central data store, we just call send. So it's like even the implementation of Longpulling taking advantage of distributed Elixir and Erlang, we didn't even have to do any effort to make this work. It was like, oh, just send the PID down, you come back up on node 2. The logic isn't even like, oh, if not on node 1, do something special. No, regardless of where you are, get the PID, call send, we message the PID, Erlang takes care of the rest. It serializes the data structure, does the encoding, does everything you need to do, and it sends you a response back, and it goes down to the client, and then this repeats. Whether you land on node 1 or node 2, it's just going to work. That PID's going to live on node 1 until the client leaves. So again, like boring implementation details, but again, like we didn't have to think about how do we solve this. And then for users, imagine that we didn't have Erlang distribution. Imagine this product feature with, I mentioned on Fly, 2% of our users can't use WebSockets. What would we have been able to do? It's like we would have had to set up some other piece of infrastructure, Redis, what have you, and it would have been huge pain, right? More infrastructure, more code, more dependencies, but no, like it just works out of the box. And index.serving is like another one of my favorite examples. So like index is, you know, an advanced project, but making it distributed was like trivially easy. So index is like Elixir's numerical computation library. So in user land, you have this feature of like index serving, which has this idea of like batching things together to send to the GPU. So locally, if you have a bunch of operations that you want to run on the GPU, you want to have some tiny window to batch those together to get the best bang for your buck by doing as much work on the GPU as you can at one time. And so Jose added index serving to make like, you know, take advantage of just like all your CPU cores, all your GPU cores with this batch run idea. And then like he may have already realized from the beginning, but then he was showing me when he implemented this, he's like, oh, we can make index distributed. And maybe he was always thinking about this. But the leap to make index serving run on a cluster was 500 lines of code with documentation. And he called me and it was explaining, and he was like, guess the lines of code. He's like, just guess. And you know, really excited. And I was like, you know, anyway, I was blown away by how short the implementation was. And this is amazing, right? So like this batching is a huge feature that you basically, it's a requirement for doing ML in Elixir. But then jumping from NX, doing ML locally, taking advantage of one GPU, to taking advantage of all GPUs in the cluster was 500 lines of code. And that's something that the Python community is just now starting to target and think about. And since we had this distributed layer in Elixir, like we just did boring distribution. And by boring, I mean like literally like the simplest thing you could think. So this may have changed, so Jose could correct me 3 days from now, but NX serving is doing random load balancing internally. So to make this distributed and doing random load balancing and discovery of other nodes that have GPUs in the cluster, it's using the built-in process group PG module in Erlang. So these nodes start up and they say, hey, I run this whisper serve thing. I can do whisper serving, audio encodings. And all NX serving is doing underneath really is just calling like enum random on the members on the global cluster and then just sending a message there, just like it would be sending a message to the local PID. And then it just randomly chooses them, and it works, and it's incredible. And again, like this is like boring distribution, right? Like yes, it's ML, yes, it's advanced, but like boring problems being solved, not having to add RAF consensus in a shockingly small amount of code. So I want people to think more of like, what does this mean for me? And I've showed 2 library examples, so you might be thinking like, yeah, okay, it's like it's neat, but like this is still like Phoenix, this is still NX. But I have really a boring example from what we did at Fly as well. So like, what did this mean? What does this mean for you? So we added like a similar trick at Fly for using this idea that we have a PID that we can talk to and the client could hold on to. So we had this like, I would say somewhat unique problem, but at Fly, we have this SQLite, distributed SQLite service called LightFS, where we replicate your database around, and we allow you to download that data, that production data at any time. So the LightFS dashboard on Fly is a live view app. It talks to our Go API. The LightFS API is in Go. And we wanted allow the user to download their database from production, right? Which is awesome, but like also you want to make sure that that's a secure thing. And also the API token, this privileged API token that we get from the live view app comes from the GraphQL API. So we need, internally we have a privileged API token that we get from a GraphQL API, and we use that to talk to the Go API. So when you click export here, there's this problem of we want to give you an authenticated URL that you can hit to download your privileged data, but we don't want to expose this privileged API token to the client to get back up to the controller. So what do we do? So like there are a lot of viable options here. Like you could use like a very aggressively short-lived token. You could encrypt the token. That way it's not readable on the client. Like there are a lot of options here that are totally viable and doable, but like it's simpler for us. So what we do when you click export is it's a live view handle event, and we use a regular Phoenix token to just put the download URL. I'm sorry, we use a regular Phoenix token, and we attach that to a download URL. So it's like 3 lines of code that we say like generate this Phoenix token for this user, and then we send a push event to the client. That runs 3 lines of JavaScript that says open this window.open, and it's at this URL. But this token argument is actually an encoded self, which is just a live view PID, some unique reference, that user and the database they're trying to download. So we don't expose any privileged API token that allows like, you know, the keys to the kingdom to the client. We just sign or encrypt the live view PID with just self, and then when they hit the controller, hey, controllers are a thing. They're still really useful. To download this file, we decrypt the Phoenix token, and then we just do a gen server call ultimately to that live view PID. So live views are processes, and processes are globally addressable. So if you clicked export and you were load balanced on the Fly proxy to another instance, it doesn't matter. We didn't even think about what happens in that case. We just do a gen server call, and we actually get your privileged token. We do some unique reference stuff to make sure that it's not replayable as well. So there's some really neat things here, not just like, oh, this is a cute example, Chris, you can do a gen server call. The semantics we also wanted was this is a single time use token. So like trying to add those semantics versus like just like an aggressively short-lived token is like the moment someone downloads this file, we don't want it to be reachable again, right? Someone's trying to demand in the middle, or they get that URL. We want to immediately expire it. So what we do here is since we have a process that's stateful up and running when they click export, that's the live view, that holds whether or not that token has actually been used once. So we don't have like some separate data store that we have to like add tokens to make sure they're single time use. It's like the moment you do gen server call, we can return to the caller the privilege token, and then we roll the reference to mean that that click of the export is now invalidated, and they would have to click export again to generate this new lease. So basically, distributed Elixir allowed us just to implement this complex handshake and not even think about the fact that we had this like stateful process that could be on another node that we had to message. We just did a gen server call, right? And then we just stream with some regular plug stuff, stream the data from the Go API down to the client. So again, boring distribution. So think less about what can I do with Raft, even though you can do some amazing things. So if that interests you, go for it. But think more about like what is this fact of having this globally addressable primitives in my system do for me? Because it's everything, right? It's every PID in the system. I can do an RPC to another node and just get information there. So it's really amazing, and it removes all this complexity. And another learning that I've had really with working on product development at Fly for a bit is like our dev debug tools are kind of lacking. So we had this big push for Heeks, which is amazing, right? It's amazing to read and write. And when I came into Fly doing some product work, I immediately upgraded like the whole app to Phoenix 1.7 with function components. And to Fly's credit, our LiveView app is like several years, 3 years old at this point. So like function components weren't a thing at the time. So I came in and basically like refactored every file in the code base to function components for good reason. And it's amazing to read and write. Like if you look at this template, you're like, okay, within markup, I have a header here, and it composes really well. If you're developing this, to read this and write this in the code is amazing. But what I discovered at Fly is like we had a lot of, we had front-end developers, we had a new developer who's just coming into Elixir that had poked around in the code base before, and the moment they went to say like, okay, I need to update the header on the page, or I need to refactor the way these buttons look to make them look nicer, what do? It's like, well, you have the app up and running, and you open up the browser inspector, and you get something like this, and you're like, where is this markup coming from? And even I hit this, right? Like any developer that's using function components in Elixir, like it breaks down this like beautiful read, beautiful to write, breaks down the moment it reaches the browser, especially with Tailwind, right? Because like it's class soup everywhere. So like if you had like IDs in the DOM, you could kind of like do a project search for an ID, and then that would somewhat help you find what's going on. But it becomes like impossible to answer without project search or intuition on like where is this div smpix coming from, right? Like so people were having trouble at Fly, and even myself, like finding like how do I just edit this one thing on the page? You have to go search the code base, find what function component's being called, trace it down, and find the markup, right? So we can do some simple things to make this quality of life, or to really improve your quality of life. So I'm going to show a demo of that, which I almost spoiled. So here's the ToDo Track application that I showed off at ElixirConf EU. I won't talk much about it, but imagine you're like, okay, I want to change the way this home thing looks, right? Oh, it's drag and drop. Okay, I want to change the way this home text looks. So you would open up your JavaScript inspector, and now we can annotate just every function component that was called just directly in the DOM as a comment. Let me blow this up. So now your entire markup tree in the DOM is just going to have the function component alongside that rendered it. So I can see that the core component's header function component was rendered here in the exact line that rendered the actual header, which is really nice. And this works on the whole tree. So like as I go up in the DOM, I can see that like my flash is rendered. It's not being shown right now. And this works even for dead renders, controllers. So like all Phoenix 1.7 apps use Heeks, whether you're using LiveView or not. And this is just going to work outside of LiveView. So if I go all the way up to the top here, I can see my actual root layout was rendered as this Heeks file. And that wraps the entire document. So like this works across your entire tree, and it's really nice because you can say like, well, where the heck did any of this markup come from? And you just trace it up, right? You're like, okay, well, it came from this header function component, and you're like, well, who rendered the header, right? Well, since the DOM is like a tree, you just walk the tree, right? You're like, okay, well, who rendered the header? And it came from the home LiveView render function at this line. So it's like very easy to find things, and we also can have figuring out how to configure. We're figuring out how to configure this, but you can even option click. Like in development, we can allow you to hook a hotkey to like just jump into the code. So here I can say like I'm just going to option click on home, and this needs to be blown up here. But it actually jumped to my VS Code, which is my configured Elixir editor, to exactly that function in that line where that was defined. So this works anywhere, right? Because the entire DOM is annotated with these comments. So I can say like, I'm going to change the size of this logo, option click, and that hopped into the Heeks file for the app layout, and then I just changed the size of the logo. So even as like a Elixir developer, not a front-end developer, this is amazing to me. I can't imagine why we didn't ship this before, but especially for the people at Fly coming in, just learning LiveView, our front-end people that aren't necessarily back-end developers, like this is like a godsend for them. So huge quality of life improvement, something that we should have done like years ago. I don't know why we didn't, because it really wasn't that difficult, but definitely check that out. Yep. And then the thing I almost spoiled as well is, like, speaking of quality of life, is like we have, in Phoenix, we have bidirectional communication that's trivial, right? So it's like we should just make use of that. It's for the same reason I want to make the Phoenix Gen Live just work broadcast across tabs, because like we can do that, and that should just be the default experience for users of your application and the developer, right? You actually just work across tabs. It's like we have it for free. So one of the things we have for free is like, well, we have this open connection to the server. Like, why don't we just show server logs in your JavaScript console? So this is not only like just like a neat feature. It's like if you've been working on live view apps or even a single page app using like AJAX requests, it's often not clear when something fails. Was it the client's fault? Was it the server's fault? Did the server actually get the message? Did the server process the message and crash? So it's probably, a lot of folks are probably familiar with, like, they click around their UI and something just doesn't do what they expected. And then they're like, okay, what happened? And you click around some other stuff. You're like, is the app broken right now? No, it's still working. And then you're like, oh, actually, I wonder if it crashed. So you go to your terminal, you scroll up like 3,000 lines because you actually have a bunch of other logs that mask the error. Anyway, so this is like day-to-day life, right? So now it's like, we have regular logs that stopped working, maybe. Hold on. Yeah, this just stopped working. Awesome. Demos. Let me see what happened here. Hold on. Oh, interesting. We'll just restart the server. So we attach a logger here. I'm actually really curious. Huh. All right, well, I'll fix that. This has been up and running for like days, so I may have had a different checkout. I'm running, this is all local. I'm pointing at local mix files, so none of this is released, but yeah, it's back. So interesting, yeah. So we attach a logger and we ship them to the client. That thing started, it was almost like it got detached or something. Awesome. So yeah, we're getting logs as we click around. So you say you're using your app, you see handle params was invoked, you get some ecto queries like you would expect. And then you're like, oh, I'm going to checkbox here, and you're like, okay, something blew up, and you just get it in line here, right? So this is like a huge quality of life thing once you have it, because you're not doing this context switch back and forth. You can disable it if you want, but it's just super nice, right? And we can do a lot of interesting things on top of this. So this is going to require a couple of releases. One is in Phoenix Live Reload, I think is where this log stuff is going to live. So we're going to have to do a Phoenix Live Reload release, I think, and then it should just mostly work by default. And we're going to need I think a Phoenix release as well. But one of the things we can do is, or live view release. But one of the interesting things we talked about is like the moment you have this like ability to send logs to the client, it'd be nice to also be able to just like enrich those logs when it makes sense, right? So imagine like the other quality, or the other day-to-day life in a live view developer is like you click something and it works, but it doesn't, well, it doesn't blow up, but it doesn't do the thing you want it to do. I guess that's all programming. But you do something and you're like, okay, that deleted the thing, but like now nothing works, or like, it didn't do what I expected. And you have to try to figure out like, well, what did happen? And your logs only tell you that like you sent the delete to the server, let's say. So we have this idea of like, wouldn't it be nice, just like this option click, if you could just enable some verbose logging mode from the client to say like, no, as I'm clicking around, like I want to see all the socket state that's logged to the client, like for this exact press, right? Because logs are pretty verbose as they are, especially with Ecto. So you don't want to always just have like, show me the whole live view state of this process at all times, but wouldn't it be nice if I could toggle that, and then when I click delete, oops, oh, I did option click there. That's actually amazing. I did option click. And it hopped directly to that function component because in my head I was thinking, oh, we could have some hotkey there. So imagine you could either toggle it in the JavaScript console, or it could be another press where I click delete and I actually have an expanded socket state that's just streamed to the client. So there's a lot of neat things we could do just on top of this idea of just log shipping to the client that I think will make quality of life huge. But you can see here, like I can actually see that like the server processed the delete, and then I actually get a diff back, so you can actually follow and trace. This went to the server. Here were the params. It processed it. It didn't crash. It sent a diff back. What was that diff? So huge quality of life improvement. Keep an eye out for that. Like I said, it's going to take a couple releases, whether it's Phoenix Live View or Live Reload. But in general, for new applications, this would just work out of the box in development. And then for existing apps, it'd be like a couple lines of configuration. So another thing that fell out of, directly out of product work was the ability to need some kind of assign async primitive in LiveView. And I think it was Andy Glassman in the community that had a blog post recently where he implemented something very similar. So this isn't a problem unique to what Fly is doing. I think everyone has this problem. But the only interesting learning is like, if you would ask me like a year ago, I've always said that like LiveView doesn't need any async primitive because we have async primitives in Elixir. It's called task, right? We have task async, we have task start trial, we have task supervisors. Like why would LiveView need to do anything? And then I actually worked on a product and it became clear why. But you actually have to use things in anger, which is really good. So like this product work has like led to like some really good features, and like you don't know these things. Like I can't build Phoenix in a vacuum. So like it's good to like use things in anger and like have to actually get things done and make it not suck, right? So the whole thing with assign async was a lot of code at Fly is doing a lot of async work. So the LiveView talks to the GraphQL API, it talks to Rust, it talks to a Go API. So on the page, any individual page may be doing multiple external requests. We also talk to a Postgres database directly. So there's a lot going on, and there's a lot of things that could fail. There's a lot of things that we want to do asynchronously so the page loads quickly. So we had a lot of code like this when I first came into Fly was like, we want to assign your organization asynchronously. So we set some assign on line 4, like it starts as nil, but then we also set some org loading assign to true so we can show the loading state in the UI. And then we started tasks. So we had a lot of things on like line 10 where you just call task async. It runs asynchronously. We have a blog post doing exactly this, and you get the successful result in a handle info. The way task async works is it links to you, and then it sends you a message with the reference and the result. But you want to make sure on line 18 that you call demonitor flush because you don't want to get the down of the task because you've already processed the successful result. Awesome. So then on line 19, you set the result and your org loading state to false, and things are good, right? So this is what we had at Fly for all over the code base. And the problem is there's multiple problems here. But what we get out of this is like we get our concurrency, right? So people reach for task async, they want concurrency. We handle our successful result. When the user leaves, they close the tab, the task exits, which is what you want because why do that work for a user that's gone? But we don't get crash isolation, and we're not even thinking about the error result. So one thing that I've learned is like in Elixir, we promote like let it crash. So you don't have to, you code only the happy path, and you don't have to think about errors. It's really nice, right? Because if things crash, it restarts, it gets back to a good working state. All of that's valid, except when you have like a user on the other side. So like so like let it crash means let it crash the user experience. So you have to be careful, right? Like there are absolutely times where you want the LiveView to crash and it can restart, but like everything we were doing at Fly was like loading parts of the UI in place, and it crashes the whole UI. So like our example is like, we have a drop down for like, we actually asynchronously fetch multiple organizations, but I simplified it to one here. But like that populates a select drop down in the layout. So if that fails for any reason, the whole UI doesn't work. And it's only for this one feature of being able to like quickly toggle between what organization the UI is showing. So it's like we should be thinking about the errors here. So I think part of this is like just conceptually we're used to coding the happy path, but when you have a user on the other side waiting on an actual UI, you don't want to crash the UI. So what did we do initially? Well, you're like, well, our biggest problem was like we would get bug reports that the GraphQL API was overloaded, so it started timing out, so the UI started failing, so users would say the whole UI is broken. So initially you're like, well, what do we want? We want crash isolation. So what do? Task supervisors. Like task supervisors start the task, they watch over it, they handle it. So the code was refactored in Fly to use task supervisors, where on line 5, you just send the successful result to the caller, and in a handle info, you get the result, you do the assign, you set the loading state. Awesome, like the UI doesn't crash anymore. But this is like not any better. It's like, yes, we get crash isolation, but we actually lost a feature, so the task is not linked to us, so when the user leaves, we have this work running until it completes to send to someone that's no longer there. We still weren't thinking about the error result, but the initial bug fix fixed the whole idea of like the live view just keeps reloading over and over. So it was like the quick fix and the intuition of using task supervisors wasn't enough. So you're like, okay, well, how do I get the task to exit when I leave, and how do I get the error result? You're like, okay, just write a little more code, right? We have the primitives. So we write a little bit more code, and we say like, well, we can do a task start child like before, but on line 9, we call process monitor. So we'll monitor that task that we started. That way we know when it fails. So on line 15, I get a down, and I'm like, okay, this thing failed, and I can get the reason, and I can populate another assign like org error to the reason it failed. That way in the UI, I can show the user, hey, we're having trouble doing X, Y, Z. And then on line 19, we've got our handle info like before, but oh, wait a second, you want to make sure on line 20 that you demonitor that monitor that you set up, because otherwise you'll get the down, and the down will be a normal down, and we don't want that. And then we set our org loading state to false. So it's like there's so much here just to do like the basic thing of like run a task asynchronously, right? And so we get this far. We're thinking about errors, and we're like, fine, you know, it's 20 lines of code, not that big a deal. But like, ooh, well, we still didn't get the task to exit when the user leaves. So we get everything we want using the primitives that we're used to, but now we're just running this work when the user closes the tab to be sent to no one. So like doing all of this and getting all the things you want is non-trivial, and you don't realize it until like you walk down this path. So it's like, this is too hard for people, right? Like this, no one should have to go and do 20 lines of code here just to get it wrong in the end anyway. You want the optimal solution. So that's what assign async does for you. So we're shipping assign async, and we also have this new function component called async result that lives in Phoenix component. So you'll just have, if you import Phoenix component, you'll have async result. And it's this rich data structure that allows you to say, like, I have a slot for loading, I have a slot for failed. So on line 4, you're just like, well, what should it do while it's loading? And you write some markup or show a spinner. And you're like, well, if it fails, like, the thing to do would be at least to be able to show the user we're having issues, right? Like, you could choose not to show it, but now, like, you don't have to think about this, oh, I need to set up a monitor, handle info down. Like, it becomes, like, on one line of code in your markup to at least show the user something's gone wrong if you want to. And then if the task is successful, it just calls the inner block and renders the inner block. So within async result, your inner block gets called and rendered when it's done being fetched. And what that looks like is like one line of code on line 14, assign async, you give it a function, you return the assigns that were fetched asynchronously. And you get everything you want. You get the concurrencies, the success result, the task exits when you leave, crash isolation, and then the error result's just baked in as a slot inside this rich data structure for you to act on if you want to. So at least if people aren't thinking about the error path, one, everything's still going to work, just your UI is going to remain in a loading state. But then if you're like, oh, well, the loading state just sat there forever, I want to be able to show something went wrong, it's like, you know, trivial. You just add the slot and it just works. You don't have to think about it. But we also have a lower level primitive called start async. So often you might want to say like, well, I'm going to assign this work, but I need some state from the socket whenever this work is complete, or I just want to run this task asynchronously, handle the result on my own. You can do that with start async. So assign async is built on top of start async. So here's like just a simple example where start async is really just going to run your function in this task that's wrapped for you, and then you get the result as a new callback called handle async. So if it works successfully, you get OK, just like if you consume a task async stream. And if things failed, you implement a handle async with an exit. So if the task exited, so the thing that you started asynchronously exited, you'll get the reason why, and you can show something in the UI. In this case, instead of having like an assign and a function component render a slot, let's say if this fails, we just want to redirect, right? We want to tell the user on the home, we'll redirect to the home page and say we're having issues contacting our billing service, try again later. So now you can do that. So start async is this lower level primitive that we use to build up higher level primitives. And this higher level primitive of async result is a rich data structure that you can also use yourself. So if you wanted to recreate what assign async does, you could do it yourself. So in this case, it's just an example of that. I can say, by default, my organization is going to be an async result loading, right? I start a data structure in a loading state, and then I run this task asynchronously that I'm calling my task. And when that task completes successfully, I just OK the result, right? Async result.OK, I OK it with a successful result. That updates the data structure, and then my template's going to reactively update if I If I'm using the async result function component, I could be using and just referencing the struct directly in my template. It's just going to reactively update. And likewise, if you had an exit, you can fail the result, async result.failed. So this is a lower-level primitive that you're welcome to use, and then we use that to build up assign async. So I think basically if you have tasks anywhere in your live view, you almost definitely want to use this. The only exception would be if you wanted the live view to fail and actually crash and remount. So it's like if you literally want a crash to take out your live view, and there could be valid reasons to do that, it's going to remount itself. It's going to basically tear everything down and recreate it. But I would say for the most part, all of the product work that I've seen within Fly and outside, folks really just want to run work asynchronously and do something when it worked. And they're not thinking about the error, but now they can at least think about what should I show to the user if there's an error. And if this is interesting to you, Chris Gregory has a talk on basically everything to think about of like, what should you do in your app when things go wrong? How should you style this async work, right? There's a lot of other considerations to think about. Not only like you want to show the user that something's happening in the background, but like, what do you do on the client when they click something, right, that does some async work? Like, is it going to return a result right away? So there's a lot of considerations to think about outside of just this assign async primitive. So definitely check out his talk. I believe it's Friday, but check the schedule and you can confirm that. And then another feature that came directly out of the product work at Fly was this idea of an upload writer. So I think Jason, a coworker at Fly, also on the Phoenix team, wrote a blog post very recently. You may have seen it. But we had this requirement of, we wanted to use live view uploads, but we needed the ability to like not write that temporary file to disk. We wanted to actually send it to our Go API. And this is like, this is a tricky problem because like you could do it inefficiently and it could work, but we have Elixir, we can do this, and we own the whole stack. So how do we make this work well? So what we really want to do with live view uploads is like we still wanted the user experience where they could just select the file, it's interactive, they get file progress, but we don't want to upload the whole file to disk because what we wanted to do was accept a SQLite database and upload it to our cloud service. So that SQLite database could be 20 gigabytes, right? So if we said let's upload the whole thing to live view, wait for the 100%, store the 20 gigabytes in a temporary file, then stream that to the Go API, like then we're storing 20 gigs on disk just to send it elsewhere, and you're also increasing the length of time that this whole thing takes. And you're not getting file progress while you're transferring the 20 gigs to the Go API. So we had this idea of like, well, we don't actually care about storing the data on disk. We just want to give you the access to this chunk stream, and you could write the upload wherever you want. So that's what we did with the upload writer. So I'll just show you an example of that real quick. So the upload writer in live view, what code base is it here, is just a behavior. And what you can do is implement, I think it's like, in our case, we wanted to open a HTTP connection to the Go API and chunk and stream, do a client stream to the server. And I think it took like 100 lines of code. Let's see. 98, awesome. So that worked out really well for, and we're even doing some, I have to force HTTP1 instead of H2 for reasons. I haven't figured out if it's a Mint issue or a Go issue or a Fly proxy issue. In any case, less than 100 lines of code. And this behavior is like super simple, where you can just say, instead of writing to disk, the live view uploader is just going to say like, okay, here, initialize your writer. So all we do is we're using Mint. We open a connection to the Go server. So the moment the file gets dropped on the page, or you choose select and hit upload, we open a connection to our Go server. We start a stream request with Mint. And then a write chunk callback exists where we just do the stream request body of each chunk as they come in. So the only thing we're ever storing in memory at once is this chunk at one time. So like if I go to the browser, let's see if this actually works. So demos, all right. Multiple things have to be working here to have this. Okay, so if I go here and I want to actually import a database to Fly, so the moment I actually click upload here, oh, it's destructive, so it's making me do this. 1 second. So this started a connection over Mint to the Go API, and each chunk is being passed and streamed over that connection. And the cool thing is, like, we're never touching disk. The only thing we ever store in memory is like 64 kilobytes of each chunk. And to close a connection, again, is another callback where we just send in a file to the Go API, and then the request is done, and then the upload completes. So as this is going, this is just in live view chunking up to the Go API. We're never touching disk, like I said, but the moment it completes, it's just going to trigger the same live view code path of like consume uploaded entry, hey, it worked, and then you say show a flash message that, hey, it was imported successfully. So the cool thing here is like all the live view primitives with upload writers remain the same. So like allow upload, you just do your normal allow upload stuff. You do the normal live file input. You get file progress, and then when the file reaches 100%, the form submit action is triggered. You consume the file, and instead of whenever you consume it, you just get the metadata from the upload writer about what it did. So like all of the primitives in LiveView remain the same. Everything just worked, except we were able to stream it to another service. So like the Go example is a cool example of Mint, but you can also imagine like you could do all kinds of neat things. Like imagine you're uploading huge CSVs, and as they're being uploaded, you have a streaming parser parsing the CSV. And that streaming parser could actually be updating your LiveView in real time as the file is parsed. So instead of like, this whole idea of interactive uploads could like truly be interactive in that like the file that you're actively uploading is actually updating the UI as it's being parsed. So there's a lot of neat things that people could do with this, and I'm excited to see what they come up with. But server to server is like 100 lines of code, which is pretty cool. And that was my demo. So I'm reusing a quote here. So if you were here 7 years ago, I gave a Walt Disney quote. And I was trying to find another inspiring Walt Disney quote for this conference. So my first quote was, if you can dream it, you can do it. And I realized, searching for a new one, that wasn't the full quote. Like the site lied to me, they cut it off. So in trying to find a new quote, I actually found like the full quote is, if you can dream it, you can do it. Always remember that this whole thing was started by a mouse, which I actually think is really applicable. So time and time again in Elixir is like, I feel like it allows you to take like small ideas and grow them into like really big ideas. And like whether that's Phoenix itself or LiveView, right? Like LiveView was started as this hack of like, I had this Phoenix channel layer. It's like, what if I could just like call render and ship a bunch of HTML to the client? Like, would that work? And it started as a small idea and grew into something like really big. Just like when like Jose started Elixir, it was like Legolang code name, or what if he could make this like language that had metaprogramming, and it grew to all of us being here. And this goes time and time again, I think especially with like the features of the platform. I mean, NX is one example. NX isn't a small idea. NX is a big idea, but it grew into like this huge idea of like distributed learning, machine learning execution, which is something, like I said, other communities are just now tackling. So it's like time and time again, the primitives of the platform let you just be like, what if I could just do this? Or like, I'm going to spec out this service. Or like me, I'm going to write a web framework and have it scale to like millions of connections. Like that was like, I had no idea what I was doing. But the famous, it took 10 lines of code change from our initial best effort approach of me not knowing what I was doing to go from 30,000 connections to 2 million connections. So it allows you to take like these small steps, start from like a humble beginning, yet grow to these really interesting outcomes. And then like LiveView uploads is a good example. It's like we wanted to be like, well, people should be able to do uploads over LiveView. And the problem we had was the WebSocket was, the WebSocket existed, so if you use a regular HTTP upload, that file might end up being sent to another server, and you don't want to ship the file across the whole cluster. So we wanted to tackle this simple problem of like, okay, we'll just allow uploads over WebSockets. And now that's grown to, okay, now you can do this really great upload over WebSockets, and now you can just stream that to a Go API. So I think like time and time again, it hasn't been like, oh, I have to rewrite and refactor everything. It's just been like you write this base using the primitives of the platform, and you're like, oh, we could just stream this to another API. Oh, NX, machine learning, and Elixir, let's just make that distributed. And like, okay, 500 lines of code, it's there. So I feel like this aligns really well, and I want folks to think about like the ability to grow your application with the primitives of the ecosystem is like something really special, and it's something I haven't found anywhere else. So that's all I have. Thanks. And I'll take questions if we have time. Otherwise, you can find me anytime in the next few days. Okay.
Anybody? I can run? Oh, okay. I can't really see. Okay. Questions?
Oh, one thing I want to show. We'll show it.
Do it live.
Oh, I'm not showing my screen anymore. Can I do it? No? It's all right. So one of the, okay, well, we can't see it, but one of the questions that comes up with distributed Elixir and Erlang is like it not being great for a lot of nodes or spotty networks, both of which aren't unfounded. But this is one example of like on Fly, I'm running a 33 node cluster currently, and what it does is like rtt fly.dev, which I'm not prepared for like everyone in the conference to hit, so we'll see what happens. But this is this is all of our regions. I'm running an Elixir node in each region, and it's pinging all the other regions as well as a bunch of AWS regions, and it gives you the round trip time. So the latency, it's basically like a speed of light tester across the world based on how the fibers run. But one of the learnings here is like, I've always heard this anecdote of like distributed Erlang is bad for like any kind of cross-region traffic, right? It's made to run on local network, which sounds reasonable. It literally was made to do that. But like this is running a 33 node cluster, and not only like cross-region, but like across the planet. So we'll see if we can see this. It's very dark here. This is the planet Earth. We can see here Seattle, and then down here is Sydney, Australia. So these are literally all the servers running, and they're each getting 2,000 messages a second. So like we constantly, if Jason's here somewhere, like this app would go out of memory, and it was because I wasn't, it's because I'm a bad programmer. But so it's funny. So like this is it's doing a ping, right, to each of these hosts every second. And then like we added, as Fly added more regions, right? It started as like 10 regions, right? We added more regions, and then we added all these like it's pinging a host in AWS and GCP as well, so you can see like if you're running your database in those regions, what would your latency be? So like as this list grew and we were doing pub sub broadcasts, like I was like, why are we going out of memory? And it turns out that like you just do the simple math of like 33 hosts every second that you're broadcasting times 33 times every, anyway, it was like tens of thousands of messages a second that were being sent. So I was able to consolidate it to like one message. Like locally we collect up the results every second, and then each node broadcasts. But ultimately this becomes 2,000 messages a second being sent over distributed, or 2,000 messages a second globally being received by each node. And we can see that like Fly, I don't know why Toronto here is receiving more data. That's actually interesting. But like everyone else is receiving about like 600, like the exact same amount of information. So in real time, you can actually see like the data going back and forth. But again, this is 2,000 messages a second going across the world, you know, Seattle to Sydney and back, and everything is like staying up, and there's like remarkable uptime. So there's like, isn't necessarily a plug for Fly other than like this is amazingly cool to be able to do, but like it's a plug for like distributed Erlang actually does quite well for you know, network spanning regions. Like if we just saw, what is this region? It was red for a while, but it had 30% packet loss a moment ago between Guadalajara, Mexico, and is this Colombia? And like everything's fine. And like I've seen like 50% packet loss for a period of time between regions. There's 30% now, and like Erlang, distributed Erlang isn't like falling on its face, right? The node's not flapping up and down. It's getting 2,000 messages a second just fine still. So like, yes, you have to think about like you're on like the global internet. Yes, distributed Erlang has like no privilege lane. So like I'm not saying ignore these problems, but I think the intuition we have about being able to run your distributed Elixir app, I think we're thinking too much about like trying to run hundreds of nodes or doing some like WhatsApp scale problems where like, no, here's an app running 2,000 messages a second on each node across the internet. It works fine. So really cool. And I forgot I was taking questions, but I wanted to show this off. So I will accept questions.